Okay, so now that we've talked about heat loss, the theory behind it, we're going to do a couple of examples. The first example that we have is just a simple wall. So if you look at the sheet that I've given you, which is here, you take a look and just zoom out. This is what we're going to use as the reference. Now I've taken snapshots of the different pieces of this sheet, so we'll use that in the PowerPoint. Going back to the PowerPoint, if we take a look at it, the wall, it's a simple wall. It's 8 feet by 12 feet. And just to be simple, that way it's very basic, we're going to make sure that it has no windows or doors. This is basically a diagram of the cross section of the wall. If you take a look at it, you can see that there's space brick, that there's an airspace that exists, that there's some insulation, additional insulation, drywall, and on either side there's an air film. So actually with any walls or windows or doors, there's always going to be the air film. So we're going to use these two values that I'm looking at right now, this 0.68 and this 0.17. We're going to use that for all the examples that we're going to do. Okay, the first step is to find the area of the wall. So if we take the area of the wall, it's going to be 8 feet by 12 feet. And if we do the math, 8 by 12 is going to be 96 square feet. The next step is we're going to find the U value. To do that, we've got to find the accumulated R value first. So what we'll do on the table, if you take a look at this picture that's right here, is I've copied and pasted it directly from the sheet. You can see that right here. I've gone ahead and gone through that there, listed all the different pieces. I go and I fill in the numbers according to the cross section that's on the first page, and I go ahead and add up the total resistivity, and it's 16.64. So I just basically filled in all the numbers up to this point, and then just added them together here, and that sum is 16.64. Now, in order to get the U value, we have to take the reciprocal of the R value. So I'm going to take 1 over 16.64, and I get 0.06. Okay, moving on, the next step is we have to find the design temperature difference. This is the same thing as delta T. So these are the values that the sheet gave us. So we're going to take the 70 minus the 5, and the delta T is going to be 65 degrees. Now we can go ahead and calculate our final answer using the equation Q equals UA delta T. So here is the A, the area that we calculated. Here is the U value, and there is the delta T. If we go ahead and do the math, we'll see we come up with a heat loss of 374.4 BTUs per hour. So that is our total heat loss for the wall example. Okay, now we're going to move on to a little bit more complicated example for an entire room. Okay, so this is in the sheet that is located here, and this has also been provided to you on your materials. Okay, and we'll close that out and we'll use those cross sections. So this is the room. We're only going to need to worry about the exterior walls, the ceiling, and the floor. So if you take a look at this room right here, this is an interior wall because it goes to another room, and so is this. So we only need to worry about the two walls that have the windows and the doors in there. Okay, so moving on, the first thing that we're going to do is, and this is also some other pictures that were given, these are the cross sections that exist for the various pieces. You can see that this is the exterior wall. Here, this is the floor, and there's probably a crawl space below. And then here is a ceiling. Okay, now we need to also add the air films to all of these sections and also the doors and the windows. So we'll have to remember to add these two values. And I got those two values from the very first wall example that we did. Okay, moving on, the first thing we're going to do is find the areas. So with the windows, if you look back at the picture, it says that there are 6 by 5 each window. So I'll go back there and find 6 by 5, and there's 2 windows, so that's 60 square feet. The door is 3 foot wide by 6 and 8 inches high. Now, if I convert the 8 inches to feet, this is what I have. And I go ahead and calculate that. We're going to go ahead and round that to 20 square feet for simplicity's sake. And the room size is 18 by 12. So that means the ceiling and the floor size are exactly the same, 216 square feet. Now, we'll calculate the walls last because we have to make sure that we take out the windows and the door. So here is the one north exterior wall. Here is the west exterior wall. And then we go ahead and subtract the area of the window and the area of the door from it. And we go ahead and do the math, and we end up with about 160.02 square feet. And we'll round that to 160 square feet. Okay? Now the next step is we're going to calculate the U values for each of the cross sections. So you can see what I did here is I went ahead and calculated it for the windows, and we get the 0.365. Now you might ask, where did I get this 1.89 number? There is another sheet that I've been given to you, that's been given to you, called the residential coefficient sheet, and it has insulating glass there. So that's where we got that value from. Okay, the walls, all of these values came from the cross section except for the air films. So we go ahead and calculate that out, and we end up having 0.057. Then we have the doors, 1.82 and 0.68 and 0.17 for those values there. And that gives us what we need for the doors. Again, this 1.82 came from the residential coefficient sheet, and I basically used the value for the door. Then we've got the ceiling values here, and we go ahead and calculate that out. And then we go ahead and calculate the value for the floor, and we end up with these numbers. Okay? All right, moving on. We're going to go ahead and calculate next the design temperature difference. And we're going to use a value of 70 degrees on the inside and 40 degrees on the outside. So that gives us a delta T of 30. Okay, now we're going to go ahead and calculate the Q value, the heat loss for each area. So the windows, I use my QA delta T, and that gives me 657. For the walls, I use the 0.057, 160, and 30. And you can double check those numbers if you like to get this value. And I go ahead and do the math here as well. All the math is very simple. It's just the UA delta T, so it's some simple multiplication. We just have the different pieces that we have to worry about. Okay, the next step is we have to worry about infiltration. Now, if we look at the room, the picture of the room that was given, I'll go back to that real quick. You can see I'm either going to have north-south or east-west infiltration. If I look at the north-south walls, that's going to give me the worst case infiltration, so that's what I'm going to use. So it's got the window and the door in there. So I go back to that. The perimeter of the window is going to be 22 feet. The perimeter of the door is 19.4 feet. I'm going to calculate the infiltration with that equation, 1.08 CFM delta T for my window. Now for my window, I have to remember to take that 75%. Okay, the reason for that is the windows they don't have as much of a leakage around them as the doors do. Okay, and when I get that finished, I go ahead and add those numbers together. Okay, now the next step, which would be the final step, is I'm going to go ahead and I've calculated all my individual values. I've calculated my heat loss through my walls, windows, floor, ceiling, and then also my infiltration. So I'm going to go ahead and add all of those values up, and that's going to give me a total heat loss of 3,154.7. So we can say that that's 3155 BTUs per hour, and then we are all set.